Hi, and welcome back to the channel. Let me show you how to solve some problems like high voltage or low voltage or shading of some of your panels. We will go through all four types of the solar panel configurations to get the perfect one to solve your problems and to get your solar system running at peak performance. Don't forget, you can rewind at any time or click the chapter links in the description below. All right, let's get started. We're going to start with explaining a single panel. Every solar panel has a voltage and a wattage and an amperage. You'll find this on the labels on the back of the panels. So if you take one of these panels and you flip it around, on the very back there's going to be a panel. If you're purchasing it online, then you can look up the spec sheet and you can find this information. It's very important that you use this information in order to determine how big the panels are so that you know exactly what you're calculating and make sure it'll fit in your charge controllers. So let's start with a single panel, and we'll walk through each of the steps and each of the configurations so that you get an idea of how to configure each one of them. So the first one would be with this type of a panel. If you ran this down to your charge controller, it would run down with just a wire straight off of the positive and a wire straight off of the negative. You are going to have a 12-volt system, and it's going to be providing 10 amps, and that is going to be 120 watts at max. Keep in mind, these are all max readings off of the solar panel specs. So, all right. So next, let's talk about parallel. And when we talk about parallel, we're talking about two of them running together. So what would happen here is that you would have both of your positives run down into the charge controller, and both of your negatives run down into the charge controller. Now, these will form together at the very end and connect, and they will in turn, when you run things in parallel, the voltage stays the same. This is like connecting two parallel batteries or having two streets. The voltage or the speed in whichever one's going stays the same. So in this case, you still have a 12-volt connection, but what has changed is now the amperage. You have 10 being provided from this one and 10 being provided from this one, so your amperage is where you're going to see the change here, and it is going to be 20 amps. And of course, because you have 12 volts times 20 amps, which is 10 times 20, you're going to have 240 watts. As you can see, it is exactly double of this one because you have two panels running down the same street, going at the same speed, 12 volts. Everything works out to be just fine, and you have 240 volts. Now, let's talk about the next case scenario, which is a series panel. And series, as the name implies, we're going to put these, instead of having these panels travel together down a parallel path, we are going to put these panels and connect them in series like this and have a single cable come down. And what this is going to generate is quite different than what you have with parallel. Within parallel, all the voltages stayed the same and the amperage doubled. In this case, what happens is the voltage is now added together, just like it would be if you take two batteries and you connect them in parallel. You take two 12-volt batteries, you end up with a 24-volt battery. You put two batteries in parallel, you end up with a 12-volt battery that's twice the size. Same thing's true here. So you end up with 24 volts, but it remains at 10 amps. And the reason it remains at 10 amps is because now the panels are in series as opposed to parallel. So 24 volts at 10 amps, which is 24 times 10, leads us back to 240 watts. So once you have these three techniques in mind, let's make a third scenario where we combine the two. Let's start off by connecting these two panels in series, and then let's connect these two series in parallel, and what you end up with here is as you would guess. Let's walk this through one at a time. This series here is going to produce the same as this, 24 volts, 10 amps, and 240 watts. This series is going to produce exactly the same thing, 24 volts, 10 amps, 240 watts. But then they're going to be parallel. So what we're going to do is on the parallel side, the voltage stays the same. So we know the voltage is going to come down here to 24 volts. I'm going to put that in the middle. Going to come down here to 24 volts, and then we know that we have them in parallel, which means the amperage is also going to go to 20. So now you have 24 volts at 20 amps, which brings us to a grand total of 480 watts. And as you can see, this can easily be adapted to. Now let's talk about naming, because this is something that is very common, and it's important that you understand how these are named. If you have two panels in parallel, this can be depicted by writing it like this. You have 2P. If you have two panels in series, then this can be depicted as writing 2S. And then finally, when you combine them, you would combine them in the way that they're listed. In this case, first we are seriesing two sets. So we're going to say 2 in series, but there's also 2 in parallel. And this will tell them if I have 12 volt panels at 10 amps going 2 series 2P, exactly how you want them hooked up. And you can use combinations of this to come up with practically any setup for any charge controller on the market today. Now that we understand how to parallel panels, how to series panels, and how to put series panels in parallel, follow me along in the next two use cases where I show you how my RV is configured and where my coffee trailer is configured, and put this to practical use. All right, let's get started on the use cases. In the use cases, we need to start off with some information about the solar panels themselves. And in this case, I wanted to highlight the panels that we're going to be looking at today are based on this current information here. Now I'm going to go ahead and bring up a big screen of this in a picture or from the stat page so that you can see them there. In the stat page, you'll notice under electrical specifications, these are 370 watt panels where the open current voltage is 41.4. The open current voltage means that you take a meter and you put it to the panel, and that's the voltage that it should have when you have power coming out of that panel in good sunlight. And this is what you're going to want to use when you're doing the calculations for what kind of charge controller you need and what the maximum power output could be. The next two important columns that you'll see, and I put them up here on the board for reference, is the rated voltage and the rated current. The rated voltage multiplied by the rated current should give you just under the 370 watts, which is where they come up with the 370 watt panels. We will be using the open circuit voltage so that we make sure we have the right sizes for the charge controllers that we're building today and understand which charge controllers we need. And we are also going to be using the current from the rated current. Let's get back to the use cases now that we understand the type of panels, and what I've written up here is a couple of these panels. So when I built the RV, I had a couple of panels left over. And with these leftover panels, I knew I wanted to build out the coffee trailer, and I intentionally ordered a few extra. I was hoping I'd be able to get all 12 of them on here, and I had to find some extra panels for that. I couldn't. I could only fit 10. So what I did is I took these two extra panels and said, let's build a small system for the coffee trailer to run refrigerators overnight. The solar system that I devise here runs all of the refrigeration overnight, and then the next morning when the power comes back on, everything goes back to normal. The batteries charge off of these two solar panels, which are placed on the roof. So what I needed to know is what type of battery did I need and what type of charge controller did I need. I am going to run two refrigerators and have them both kick on at one time. So I started off by measuring the surge, and the surge in each one of them ended up being about 1,000 watts. That meant if I wanted to run both of them, I needed 2,000 watts of surge capacity. So I've got a 2,000 watt inverter with a 3,000 watt surge capacity. This allows me to ensure that both refrigeration units can kick on at the same time. That said, I made the decision to go with a 24 volt system. Now, in order to do 740 total watts divided by 24 volts, I need to build a charge at 30 amps. I chose a Victron 30 amp charger, 100/30, which gives you a 30 amp charger at 100 volts, which worked out really well because what I needed is to either A, run these in parallel like we talked before, or run these in series. Now, there's an important factor here that the higher the voltage, the less voltage loss you have. So what you want to do is you want to run these at the highest optimum voltage that you can get. What I chose to do is to run these two in series, and when I did that, what I end up with a system that is running on 82.8 volts and 10.72 amps. This was a perfect fit for the system that I was designing here and allowed me to easily get both panels up on the roof, have all the efficiencies of having them in series and bringing the voltage up. Use case 2 was a little bit more complicated. I had two, this runs on a 6000 XP. The 6000 XP has two inputs that can support up to 4,000 watts each. Now, the maximum voltage, and I'm going to bring the stat sheet up on the screen so that you can see that. And I'm going to, if I remember correctly, it is around 420 volts. Optimum operating is somewhere around 360 or 380, somewhere in that area. And minimum is 120. Originally, I hooked this up with all 10 panels in parallel or in series. What I learned is that on the RV, where I have the 10 panels, and you'll see a picture of that now, this had different shading from this. If I park in an RV park, a lot of the times the front of the unit would have shade when the back of the unit didn't, or the back of the unit would have shade when it didn't. This is a 42-foot RV. And therefore, with that 42-foot RV, you run into issues of you're going to have shading in certain aspects. So what I chose to do is to divide this into two sections and to create two series of panels. Now, this series of panels was basically taking the 41.4 maximum volts and creating a 207 volt max, and then it was having a rated operating voltage of 34.5 and creating a 172 volt operating voltage, meaning it was over the 120, but it wasn't going to easily be brought down below the 120 when it tried to pull power from it. So then I created a second string, and I did exactly the same thing. This string, I put these in series, and it created the same stats as up here. It was basically 370 times 5. Each one had 1,850 watts. It had a maximum voltage of 207, an operating voltage of 172, which matched perfectly to this over here. And it allowed for it to fit right in between the minimum operating voltage of 120 and the high operating voltage of 220. And it was below the optimal, but it still was well within its operating range. Then I ran each one of these to the charge controller, an independent line within the charge controller. This allowed me a very important thing, which you'll see on the screen right now, for me to track the statistics differently with each of these two sets of panels. I could have paralleled these two strings together and put them into a single input if I had other inputs that were needed to go through the second line. But because I didn't, it allowed me to simply take these two strings, split them into two sets of series, and run them into two different inputs on the 6000 XP. But like I said, they could have been paralleled, and that would have allowed all of the 3,700 watts to come through a single input. So in the EG4 app, in my Solar Assistant, and in my Home Assistant, I feed this data all the way through, and it gave me the ability to see which areas were shaded, which ones were not shaded, and to make adjustments if needed, depending on where I was parking and how I was parking. So that is the RV. That is the second use case that we have in the RV. It allows you to create two series of panels of 5 each, running at 207 volts, operating at 172 volts, and outputting 1,850 watts apiece for a total of 3,700 watts with both inputs active. Then we have the coffee trailer, and the coffee trailer is running a 2,000 watt inverter. It has 2 panels on the top, charging a 24 volt system at a maximum of 30 amps with a Victron 100/30 charge controller. Both of these use cases are very real life ideas. This could be a small van, this could be a house, and both of them are very useful and should provide you with the basics of understanding how to serial or parallel or in conjunction use the parallel serial variations that we went over. I hope this helps, and I hope you've learned something, and I hope to see you on the next video. Have a good day.
Hey, thanks for watching. And now we have a video about which battery you should use, a 12 volt, a 24 volt, or a 48 volt. Click this link right up here on the screen. It'll take you to that video so you can decide which one is the best fit for your system.